Good day, everyone. I have a student who has asked me to go over some problems from a previous part of the course. And these questions go back to the first couple of days of classes where we talked about translations. Before I get to answering the students' questions, I'd like to go through a quick review here of what translations are all about. What a translation is when you take the graph of a function and you literally pick up the graph and you move it either to the left or to the right, and or you move it up or down. This is something that we can call shifts. I think in junior high math, you call these things slides. The bottom line is the entire graph doesn't change shape. It doesn't change orientation. So what we do in order to accomplish that on a graph is we take the equation of the function, which is y equals f of x in the most general sense, and we change it into y minus k equals f of x minus h. We probably would add k to both sides to get y equals f of x minus h plus k. And those two letters, you can call them letters I suppose, h and k, are better called parameters, and it's those two parameters that determine the nature of the translations. First of all, the parameter h is the parameter that tells us there is a horizontal translation. And when we talk about the amount of the horizontal translation, we don't like to use negatives. So I'm just telling you that the size or amount or magnitude of the horizontal translation here is the absolute value of the parameter h. If h is negative 8, then there is a shift of 8 units. If h is positive 8, there is a shift of 8 units. On the other hand, the character of that parameter, and by character I mean whether it's positive or negative, tells us the direction horizontally. And this is pretty easy to remember. If h is negative, then the shift is in a negative direction. A negative direction horizontally is to the left. And if h is positive, then the translation is in a positive horizontal direction. So if h is negative 8, getting back to that negative 8, what we would say is that there is a translation of 8 units to the left. Saying there is a translation horizontally of negative 8 units, I don't think in Math 30-1 is good enough. I think you need to say what direction it's translated in and how big the translation is. K, on the other hand, of course, is the parameter that tells us about the vertical translation. For the same argument kind of outlined with h, we talk about the absolute value of k being the amount of the shift or the amount of the translation. If k is negative, then it shifts or translates in a negative vertical direction, which is down. If k is positive, then it shifts in a positive vertical direction, which is up. Lastly, the mapping, and I don't know that we're going to need to resort to mapping or look at mapping to answer any of the questions that I'm about to go over. But when you take a look on the graph at what happens to x, x changes to x plus h. And the reason for that is, and note that it's x plus h, there are no absolute value signs in that mapping statement. The reason it's x plus h is if h is positive, when we add h to x, that will shift x to the right. If h is negative and we add that negative number that h is to x, it will shift it to the left. So we don't want absolute value signs in the mapping statements. And of course, y becomes y plus k. All right, so now let's get to the questions that the student had asked me to go through. The first one, and I think all of these questions are from lesson 30.1.1 part 2, if you're following along in your note package. In question 3, and I've just pasted question 3 on top of the context box. In question 3, you're given a graph of a function. The graph is y equals g of x. So I think it's important for you to understand what's going on here in terms of what's what. G of x is this function here. But g of x is a transformation of f of x equals the absolute value of x. Well, we should know what the absolute value of x looks like as a function. We learn about absolute value functions in Math 20-1. An absolute value function of y equals the absolute value of x is that V shape with its vertex located right at the origin. And when we take a look at the original location of that vertex, of that key point, I'm going to call it. It's right here, dead center in the graph. And we take a look at where that ends up being. It ends up being 2 units to the left and 3 units down. This point that's at the origin ends up being located right here. And the bottom line is, looking at those 2 graphs, it should be fairly obvious that we have a translation of 2 units to the left, and we have a translation of 3 units down. 2 units to the left tells us that h is -2. 3 units down tells us that k is -3. And now what we can do is we can build the function. When you apply h equals -2 and k equals -3 to this general template, y, the new function, equals f of x minus h plus k, what we end up with is y equals f of x minus -2, which would be x plus 2, and then plus k, well, k is -3, so we subtract 3. So that's the equation of the new function. Now, what are we going to do with that? Well, since f of x is the absolute value of x, when we are asked to figure out what f of x plus 2 is, we simply replace x in the original function with x plus 2. So what we end up with is y equals f of x plus 2, which would be the absolute value of x plus 2, and then minus 3. So the correct answer here is D. Kind of a standard run-of-the-mill question concerning the values of h and k and getting them from a graph. All right, let's take a look at number 4. It says the graph of a function f of x equals root x. We'll come back to that in a bit, about what the function f of x equals root x looks like. The most important aspect is that it is transformed into, so this function is transformed into this function, and if we know what f of x equals root x looks like, we ought to be able to figure out what g of x looks like, because looking at what I've highlighted in blue on the right side of the screen, h is positive 6, and k is positive 3. And that means whatever f of x equals root x looks like, we have to translate it 6 units to the right and 3 units up. Okay. On the other hand, we have h of x, and h of x is the absolute value of x. We'll come back to that in a bit. But it's transformed into k of x. Well, the same argument is going to be in play here. If we know what the absolute value of x looks like, then we should know what k of x looks like, because k of x is a transformation of that function, the absolute value of x. Specifically, in k of x, h is 2 and k is 4. So what is it these two functions look like before they're transformed? Well, I would say that you should probably know what they look like without using a graphing calculator. But in order to make things nice and tidy on the screen for you, I'm going to go ahead and graph these two functions one at a time, the square root of x. And I'm going to go zoom standard. It is half of a parabola laying on its side. We've talked extensively about that function later on in the unit when we investigated inverses. And the absolute value of x, well, you should know what that looks like. We already talked about it for the previous question, but that's okay. I'm going to throw it up here as well. So let's start with y equals root x. Let me just tone these down a bit for you. Let's start with y equals root x, which is the graph on the left. This is y equals root x. This is f of x. You can see that the beginning of this graph is at the origin, and the graph moves up and to the right. What that tells us is the domain of this original function f of x is greater than or equal to 0, and we can see the range is y is greater than or equal to 0. On the other hand, when we take a look at the absolute value of x, it has its vertex at the origin, and it increases upward to the left and the right, that tells us x is any real number, and it also tells us that y is greater than or equal to 0. So the question is, what's the domain of g of x? Well, g of x is f of x shifted 6 to the right and 3 up. If I were to take this graph its vertex would be at 6, 3. I'm a little high on my graph, but that's okay. The vertex would be at 6, 3, and that would mean that x is greater than or equal to 6, and y is greater than or equal to 3. So we know that a is 6 and b is 3. When we take a look at the other function, the absolute value of x, we are told that that function is translated 2 to the right and 4 up. Well, if I translate it 2 to the right, that doesn't change the range, but when I translate it 4 up, the new function will be in this location, and you can see the location of this vertex now is at 2, 4, which means y is greater than or equal to 4. And that means that c is 4. Next question 5, a comma b is a point on an original function and it's transformed into the new graph of y equals f of x plus 2. Well, listen, all that means is that since h is negative 2, and I'm going to go out on a limb here and say to you that everybody in this class by now ought to be able to know that when I see f of x plus 2, h is negative 2. What that means is every point is shifted 2 units to the left. And that means that if we start off with a comma b, a will become 2 less, but b will be the same. So the correct answer here will be b. I suppose we could have used the mapping rule that I've given you, which is x comma y turns into x plus h comma y plus k. By the way, I didn't mention this up here, but k is equal to 0 because there's no number added after the function. So if I simply take x plus negative 2, that translates into a plus negative 2 as an answer for x. We've talked numerous times about this in class. I think sometimes mapping is a better way to go, and there is certainly going to be a case that I think we're going to encounter in a minute where you want to do things algebraically as opposed to just reasoning them out. But sometimes it's just simple to say, well, listen, the thing went 2 to the left, so the x-coordinate is 2 less. Here is one that you definitely need to apply algebra to. It's quite an extensive problem. F of x equals x squared is transformed to a new function, f of x minus h plus k. Let's just pause there for a second and appreciate what that means. That means the new function is f of x minus h. Well, f of x is x squared, so that means f of x minus h is x minus h squared plus k. And in order to help us break this problem down, I want to use y instead of g of x. So this is the equation of the new function. And what we have are 2 missing parameters. I've tried whenever possible to impress on you during class that when you have missing parameters, the whole strategy that will lead you to success is centered around putting in ordered pairs and solving for those parameters. And normally what would happen is, we're told it goes through 4, 8, this new function. Normally you would have one missing parameter, and that means you could load 4 in for x and 8 in for y, and then solve for that missing parameter. The issue here, though, is when I put 4 in for x in this new equation, and I put the corresponding y value of 8, I have 2 unknowns, so I can't solve for either of those unknowns. However, since the new function also passes through 7, 11, I can build a second equation. And you learned way back in grade 10 math that if you have two unknowns, you need two equations. And we call that pair of equations a system of equations. And that's what I'm going to do. I'm going to build an equation by putting in 4 for x and 8 for y. Let's see what we get. We get 8 equals 4 minus h squared plus k. We'll come back to that. I'm going to build another equation from the 7, 11. When I put 7 in for x, I get 11 coming out for y. So I have two equations with two unknowns. I can solve this as a system of equations. I would subtract these two equations. By subtracting them, I will have k minus k, which is 0. I will have eliminated the k's, and I will have a single equation with h in it. 11 minus 8 is 3, and that's going to be equal to 7 minus h quantity squared minus 4 minus h quantity squared. So we're going to simplify this. Of course, 7 minus h quantity squared is 7 minus h times 7 minus h. And I'm not going to spend time explaining that. You FOIL that out, you get 49 minus 14h plus h squared. And then we're going to subtract 4 minus h quantity squared, which of course means this. So we're going to subtract 16 minus 8h plus h squared. And if that's what you write, then you've made a fatal mistake, which goes all the way back to grade 8, I suppose. We are subtracting 4 minus h squared. We're not simply subtracting part of 4 minus h squared. This is 3. I'm going to subtract these in pieces. I'm going to look at taking the 49 minus the 16, which gives me 33. I'm now going to take the negative 14h minus the negative 8h. Negative 14 minus negative 8 is negative 6, so I get negative 6h. And then h squared minus h squared is 0. We catch a lucky break there, because if h squared didn't go away, we would have a quadratic equation. And this is a lot simpler with a linear result. I can add 6x to both sides. Well, 6h, I misspoke there. And subtract 3. So I get 6h equals 30. Dividing both sides by 6, I get h is equal to 5. Of course, we do need to know the parameter k, but all we have to do is go back to any equation that has h and k. It doesn't matter. I'm going to use this one because it's kind of out in the open, and put in the value that we got for h. So I have 11 equals 7 minus h. We got 5 for h squared plus k. Pretty simple matter to say 11 equals, well, 7 minus 5 is 2. 2 squared is 4 plus k. So that means that k is 11 minus 4, which is 7. H is equal to 5, k is equal to 7, so the answer to this question is 5, 7. And if you were to graph y equals x minus 5 quantity squared plus 7, you would discover that it passes through 4, 8 and 7, 11. Question 9 is one that I think if you start to approach it algebraically, you create a lot more work for yourself. The bottom line is we have an original function, O for original, and it's transformed to this function, g of x equals f of x minus 7 minus 2. And really, I don't think we want to build the function g of x. This is the transformed function. Original one is up top, transformed is here. What we want to say by looking at g of x's structure in the equation is that this will be a translation of 7 units to the right and 2 units down. Now what are we asked? We're asked for the location of the vertex of g of x. Well, the original function has a vertex at negative 3, 7. That goes back almost to Math 20-1, where we talked about functions that are quadratic. You didn't use H and K, you used P and Q, but you should be able to look at that and say that the vertex of that function is at H comma K. Or if you want, P comma Q. H is -3, K is 7. Or P is -3, Q is 7 if you're stuck in a Math 20 mode, and that's fine. So all we need to do here to answer this question is say, what happens to this point right here? What happens to this point when we do this to it? And the answer is that -3 will have 7 added to it. So the new vertex, I'm going to call it V prime, will be that -3 plus 7, which is 4. And the y coordinate of 7 is going to lose 2. 7 minus 2 is 5. So if the vertex is at A comma B, A is 4, B is 5. I think if you use the function notation to build the equation of the new function, it's more work. Finally, number 10. Now, strangely enough, number 9 was a quadratic function that underwent translations, and it was easier to just reason out what the answer would be. Whereas question 10 is simply a linear function. You cannot reason this out. You need to use algebra along with the function notation. So you're told that the point 5 comma 35 lies on this function. And this function has a missing parameter of k. We don't know what k is. So what that means is we are going to have to put in 5 and 35 for x and y in the transform function. The only difficulty here, and this is actually quite a confusing question for students, is g of x is not given to you. You're not given the equation for g of x. You're told, however, that f of x is -6x plus 10, and g of x is f of x minus 5 plus the parameter k. Now, what does f of x minus 5 mean? F of x minus 5 means that what you have to do is take this x minus 5 and put it right here. And if I do that, then this whole thing becomes f of x minus 5. Remember, we talk about function notation in class a lot. F of a quantity simply means put that quantity in for x in f. So g of x is going to be equal to -6 times x minus 5 plus 10. That is f of x minus 5. This thing right here is this whole thing here. But we still need to add k. And now what we can do, we can simplify this. I would recommend simplifying this. -6x plus 30 plus 10 plus k. And because I am about to put in 5 for x, and was it 35 for y? Yep, 35 for y. I'm going to toss the function notation out the window and just talk about y equals. So what do we have? We have -6x plus 40 plus k. So I put in my ordered pair. I load in 5 comma 35. Simplify it. What am I getting? 35 is equal to -30 plus 40 plus k. 35 is equal to 10 plus k. Subtract 10 from both sides, you get k is equal to 25. To the student who had asked about these questions, I really hope that all of this helped. And to anybody else, I hope you got something from it as well. Have a wonderful rest of the day. We'll talk to you soon. Take care.